That's so cool. So I had this 1/4-inch brass rod. There's 1/4-inch magnet grooves. I want to, when you surface grind the table, it fills the magnet grooves up with all kinds of crap. So if I take the brass, it don't stick to the magnet, and I can just wipe this out. The first time's the worst as far as crap in the table, because you're forcing the debris all in the grooves. And so brass or micarta or whatever else works great. And so I need to come on this side. I have a little stop here. And so that's there. And then just a little bit of sandpaper, I'm just gonna go and just kind of hit the edges, so as I wipe the stuff off in the future, I don't slice my finger, which will probably it still happens, but not on this. Anyway. So there, we're done. Now my table's flat. So the whole point of that is, oh shoot, it's just a cool thing I could do with the surface grinding attachment. It's a cool way to make a lot of types of cutlery. Now, I had some other demo blades I wanted to bring out, but I mean, this was a blade that was done on the surface grinding attachment. Now, the patterns it's going to work for, it's going to work for a straighter cutting edge. Some curves okay, and then the cutting edge not going, so the cutting edge being lower than the handle. And if it's a heavy straight edge, but is that, and that'll be on the screen. Yeah, there we go. Is that as I put my cutting edge down, there's nothing hanging down here in where the cutting edge is going to make it go away. So with these profiles, they're blunt for a reason, and I'll get there, is when I put the cutting edge down, this is still up sufficiently. And the other thing I try to do is I try to get it to where it's no more than 2 inches wide to the highest point on here. And so what I mean, this highest point. Must be time for something, because I hear my alarm clock going off, but I don't know where my phone is, so if anybody tracks down the rooster, there we go. Yeah, so when I work with a pattern or kind of figuring out if this is going to really work for what I'm doing, I usually just keep a piece of 2-inch stock around, and if I put my edge down and this don't come up, then I'm okay. Now that only matters if I'm going to bring my bevel all the way through. On here we stopped at 1 inch. So when I go to define a bevel, so as far as getting the profiles, I'm not going to go that much in there. I'm going to get to define the bevel and make some sparks, because it gets boring otherwise. And then the details will come later. But so this was a little more tricky, because you're going to a specific thickness and a specific width of the bevel. And so, you know, the stuff's a little bit more critical. And you want to keep that crisp line, and so that's a little bit trickier. So I'm just, where you bring the bevel all the way through, meaning you're not going to see a grind line, is nicer. However, there is such thing as too thin. If I run too gradual of a V or too gradual of an angle, then that cutting edge is going to stay so thin for so long that it's going to flex too much. And so if I go a little bit steeper bevel, I can actually take the edge thinner. And so, like if I'm going to bring this bevel back, so these are made to where I'm going to bring my bevel all the way through the top up here. And that matters that that we put the cutting edge flat, because we're going to grind a wedge parallel to that. So my grind line is going to be parallel to my cutting edge. And so I measure up this high. And so that's the measurement I want to take. Of course, I plan this to where I know, okay, it's 2 inches. So rather than explain math a lot of the times, I just made a spreadsheet. And so I know I'm 175 thousandths, but I'll grab the calipers anyway.